In the previous video, we discussed example 2.5. In this one, we are going to be talking about example 2.6, and this one is related to relative lowering of vapor pressure. So the vapor pressure of pure benzene at a certain temperature is 0.850 bar. A non-volatile, non-electrolyte solid weighing 0.5 grams when added to 39.0 grams of benzene, whose molar mass is 78 grams per mole. Vapor pressure of the solution is then 0.845 bar. What is the molar mass of the solid substance? So we need to find out the molar mass, and this is basically the calculation of the molar mass of the solute using the relative lowering of vapor pressure. So we have been given the following values. Or let's start with the equation rather. Okay, so according to the calculation of molar mass using the relative lowering of vapor pressure, this was the final equation that we got. So P1 naught minus P1 divided by P1 naught is equal to W2 into M1 divided by W2, divided by W1 into M2. Okay, so P1 is related to our solvent and 2 is going to be our solute. So we need to figure out the value of the molar mass of the solute. So we've been given the following values, and basically it's going to be just substituting the different values that have been given. So we've been given, first of all, the vapor pressure of pure benzene, that is 0.850 bar. So that is P1 naught, that is equal to 0.850 bar. The next one is solid that weighs 0.5 grams. So this is the solute, right? So this is the mass of the solute. So W2 equals to 0.5 grams. The next one is the mass of the solvent, that is going to be W1, which is the mass of benzene, 39.0 grams of benzene. So 39.0 grams. Okay, and we have the molar mass of the solvent, which is benzene, that is 78. So M1 equals to 78 grams per mole. Okay, the last one is the vapor pressure of the solution. So the vapor pressure of the solution is given, which is P1, because this solution consists of a non-volatile solute and a solvent. So the vapor pressure of the solution will be equal to the vapor pressure of the solvent in the solution. So we're just going to say P1 equals to 0.845 bar. Okay, so all we have to do is substitute all of these values to calculate the value of M2. So I'm just going to substitute it as it is, and then we can go from there. So it's going to be 0.850 bar minus 0.845 bar whole divided by 0.850 bar equals to W2, which is 0.5 grams, into M1, which is 78 grams per mole, and then you have W1, which is 39.0 grams, and then you have M2, which is what we need to calculate. The reason I like having the units is it helps make sure that we are doing the right thing. Okay, and in the end you should have, since you're calculating the molar mass of the solute, you should be left with grams per mole. So let's start simplifying this. So this you get 0.005 bar divided by 0.850 bar, and this is equal to, um, since we are multiplying this and this, and since this is all multiplication, we can just cancel the grams in the numerator and the denominator for these two. So you get 39 grams per mole when we multiply this with this, divided by 39.0 into M2. So now we can just cancel this and say this one time, right? And so, um, okay, so this when simplified gives us 0.00588, and here we can cancel bar and bar, and so that will not give us any units, is equal to 1 gram per mole divided by M2. Now we can just switch these two up. So you get M2 is equal to 1 divided by 1 gram per mole divided by 0.00588. And this, on simplification, will give us 170.06 grams per mole. Basically, what we're doing in this question is we just use this equation of calculation of relative lowering of vapor pressure, and we just had to substitute it. I think the most difficult part of this particular question is the fact that you need to substitute the right thing, and you also need to do the math right, which, yeah, that's pretty interesting. So that we're done with the example 2.6, and the next video will be continuing with the example problems.